Dear friends, students and learners, I am Shashank Srivastava from the School of Engineering and Technology, Indira Gandhi National Open University. So before this session, we have discussed about friction and the lubricants and tribology terms. And in lubrication, we have seen certain types of lubrication and some things were left. So we will be discussing in this session. So what are the additives then? So there are certain types, like there are oiliness carriers, extreme pressure ones, then the antioxidants one, anti-foam ones, and anti-wear ones. So now we discuss about the synthetic lubricating oils. We have seen the natural ones before, now the synthetic one, which is prepared, manufactured by human beings for more severe operating conditions like those existing in aircraft engines. So this is the place of application for these kind of oils, in which oil may have to be pumped at -50 degrees centigrade, but at the same time when the aircraft is landing or taking off, the same oil will get heated to as high a temperature as 250 degrees centigrade. So the range of variation is around 300 degrees centigrade, from -50 to 250 degrees centigrade. So then such kind of properties are needed, that it should not freeze also, and it should not break down also at high temperature. Thus the high temperature and high operating pressures require such kind of oils which give us superior resistance to oxidation with a high viscosity, but at the same time they must possess sufficiently low freezing point, and the lubricant should be non-inflammable as well, because if the temperature is going up to 250 degrees centigrade, it can catch fire if it's that ignition point is not high. And then chemical synthetic oils possess distinguishing features such as high flash point, high viscosity index, thermal stability, and inflammability. Like I told you, that it should not burn at a very low temperature, and at least above 250 degrees centigrade is flash point. That's why high flash point is given here. Then comes the greases or the semi-solid type of lubricants. Till now we discussed the liquid type of, now we discuss the semi-solid, which was the second category according to the physical state. So lubricating grease is semi-solid, consisting of soap dispersed throughout a liquid lubricating oil. The liquid lubricant may be petroleum oil or even a synthetic oil, and it may contain any of the additives for specific requirements. So greases are prepared by saponification of fat with alkali. So saponification is a process where we are using the fat and the oil to make soap like things. So that is one process, and this is followed by adding hot lubricating oil while under agitation. So this way grease is prepared, and total amount of mineral oil added determines the consistency of the finished grease. So what kind of consistency we need, accordingly we add the mineral oil to this grease. And the structure of the lubricating greases is like that of a gel. You may be using gel in many places, like toothpaste also comes in form of gel, and shaving cream also. Soaps are actually gelling agents which give an interconnected structure containing the added oil. At high temperatures, the soap dissolves in the oil, whereupon the interconnected structures cease to exist and the grease will liquefy. So at high temperature, again the grease may become liquefied. So its property of providing lubrication to the semi-solid type method will go away. Consistency of greases may vary from a heavy viscous liquid to that of a stiff solid mass. Like I said earlier, they may become solid at some point also, and they may become completely liquid also at some point. So that consistency varies. To improve the heat resistance of grease, inorganic solid thickening agents are added. So again, additives are always there which can improve the property as per our need. Greases have higher shear or frictional resistance than oils, and therefore can support much heavier loads at lower speeds. So this is a very good thing, a very good property of the grease, that it can support heavier load because of higher shear or frictional resistance. And where they are used, like in situations where oil cannot remain in place due to high load or low speed or intermittent operation or sudden jerk, etc. And in bearing and gears which are working at high temperature. And also in situations where bearing needs to be sealed against entry of dust, dirt, grit or moisture, because greases are less liable to contamination by these. So greases are not affected by such kind of things, so we can use in these places. And finally, in situations where dripping or spurting of oil is undesirable, like oil may cause certain contamination, liquid type, so then we will have to use grease, because unlike oils, grease if used do not splash or drip over articles being prepared by the machine. So what are the soap functions? We have discussed about soap. So what are its functions actually? So main function is to act as a thickening agent, so that grease sticks firmly to the metal surfaces. That's what its function is. However, the nature of soaps decides three things, that is temperature up to which the grease can be used, then the consistency of the grease, and finally the water and the oxidation resistance is also determined by these soaps. So there are certain important greases we will discuss here. The first is the calcium based grease, which is an emulsion of petroleum oils with calcium soaps. How it is prepared? We add requisite amount of calcium hydroxide, that is CaOH twice, to a hot oil like fallow while under agitation. So this is the process of preparation. And what are its properties and application? These greases are very cheap and are very commonly used, and they are insoluble in water. They are satisfactory for use only at low temperatures, because above 80 degrees centigrade actually oil and soap begin to separate out, so then we cannot use them. Then there is the soda based type of grease, which comprises of petroleum oils thickened by mixing sodium soaps. What are the properties of these? They are not water resistant, because the sodium soap content is soluble in water, so we cannot use it for water resistant purposes. But it can be used up to very high temperature like 175 degrees centigrade, so it can be used in high temperature applications. So the applications are like in ball bearings, when the lubricant gets heated due to friction, because it can withstand high temperature. Then there are lithium based greases also, which are petroleum oils thickened by mixing lithium soaps, and they are water resistant. So the earlier one was not water resistant, this one is lithium based one, and thus it is suitable for use at low temperatures up to 15 degrees centigrade. Then there are the axle greases. Axle, you know, and there are in vehicles axles. So these are resin greases prepared by adding lime to resin and fatty oils. The mixture is thoroughly mixed. This is the process. The mixture is thoroughly mixed and allowed to stand. When grease floats a shift mass, filters like talc and mica are also added to them. And these axle greases are water resistant and suitable for less delicate equipment working under high loads and at low speeds. So after discussing the semi-solid type of lubricants, we move on to the solid type. So till now we have discussed the liquid type and the semi-solid type. So what are the solid lubricants now? They are employed in certain operating conditions where lubricating film cannot be secured by use of lubricating oils or greases. So in such situations we use solid lubricants. And also in places where there is contamination of lubricating oils or grease is unacceptable. Then where the operating temperature or the load is too high even for a semi-solid lubricant to remain in position. So such is temperature or operating condition that even the semi-solid lubricant cannot maintain its consistency. So then we have to go for solid lubricants. And finally, combustible lubricants have to be avoided. Then we have to use this type of solid lubricant, because generally liquid type and semi-solid are more prone to catching fire. Solid lubricants are used either in the dry powder form or mixed with water or oil. So they can be used in both ways, like in dry powder form or by mixing it with water or oil. So solids fill up actually the low spots in the surfaces of the moving parts. Like we have discussed earlier, there are valleys or there are certain low spots, so these will fill that portion, and thus they will form solid films which have low frictional resistance. Usual coefficient of friction between solid lubricants is between 0.005 to 0.01, so it is quite low here also. And the two most usual solid lubricants employed are the graphite and the molybdenum disulfide. So these are the most common ones. So we now discuss the graphite. Graphite we have also seen when we were discussing about the iron and steel, and we have seen how it was helpful there, and it is generally in the form of flakes. So here also we see it is a very soapy thing to touch, and it is non-inflammable and is not oxidized in air up to a temperature of 375 degrees centigrade. In the absence of air, it can be used up to much higher temperatures. So if air is not there, then we can go beyond 375 degrees centigrade also. So it can be good for high temperature applications. And what are the useful forms of graphite? Graphite is used either in the powdered form or as a suspension. Suspension of graphite in oil is known as the oil dog, whereas the suspension of graphite in water is known as the aqua dog. And this is done by emulsifying agent like the tannin. So oil dog, actually the emulsion of graphite in oil is particularly useful in the internal combustion engines because it forms a film between the piston rings and the cylinder, and thus gives a tight fit contact, thereby increasing compression. And the aqua dog one is useful where a lubricant free from oil is needed. Suppose there is certain situation like in case of our foodstuffs, we cannot have certain oil which is not good for health. If we consume it, then we don't need that oil. So in that case, we will have to use the water-based one, that is the aqua dog. So what are the uses of the graphite then? As they are generally used in air compressors and lathes. And the second one, that is the molybdenum disulfide now. So these possess very low coefficient of friction, and they are stable in air up to 400 degrees centigrade. So they are even better than graphite if we take the case of temperature. In air they can sustain up to 400 degrees centigrade. And its fine powder may be sprinkled on the surfaces sliding at high velocities when it fills low spots and metal surfaces, forming thin film. So this is the same type of process as graphite, and it is also used along with the solvents and in greases. Besides graphite and molybdenum disulfide, there are other substances also like the soapstone, talc, mica, etc., and these can be used as solid lubricants. So now we discuss about the properties of the lubricants, general properties. First one is the viscosity. And what is viscosity actually? Viscosity of a fluid is the property which resists its flow or shear. So if there is a certain fluid which is moving, then if resistance between the layers of that fluid will be known as viscosity. It will be the resistance to the motion of the fluid. The quantitative measure of this property is actually given in terms of the dynamic or the absolute viscosity. So absolute viscosity is defined as the force required to shear a layer of unit thickness at unit velocity, and its unit is poise, general SI unit, and there is the CGS unit also, which is known as centipoise. And the ratio of absolute velocity to density of oil is called the kinetic viscosity. So kinetic viscosity deals with the internal resistance actually. So there is the SAE, there is the body which deals with the fluid and the lubricants all. So SAE oil classification actually uses the absolute viscosity, while ISO classification uses the kinematic viscosity. So since both absolute viscosity and density are affected by temperature, each value must be described for a temperature only. So this absolute and kinematic viscosity both have to be described at a certain temperature only, because they change with temperature. And then what is volatility? This is also a property of lubricant. Volatility of lubricant is like the tendency of going into the vapor phase, how quick it can go into the vapor phase or how slow. So that will be told by volatility. and it is very important in cases where lubricant is used in the form of thin films, as in case of boundary lubrication, because if it goes into vapors very quickly, then there may be nothing in between the contacting surfaces. So example is like rolling contact bearings. Then there are chemical properties also of lubricants, like the oxidation. So lubricants are oxidized, and the property of oxidation varies with different lubricants, and it depends upon the composition and purity of the lubricant. Actually, oxidation of lubricants decomposes the lubricants and lubrication is affected. So this one is very important. Then there is the hydrolysis, where a chemical reaction by which various types of lubricants are decomposed. So the examples are the esters. So hydrolysis is a kind of chemical reaction. Then the pyrolysis. So when organic liquids are exposed to temperatures higher than 300 degrees centigrade, there is a tendency to crack. So these liquids crack. Then this phenomena is known as the pyrolysis. And this rate of cracking actually differs with different compounds depending upon their composition. And it has been found that cracking is generally a free radical chain reaction and is generally accelerated by oxidation. So lubricants used should not crack under lubrication. So we have to see that oxidation also doesn't take place, because it will lead to cracking. Then we have one more property, that is viscosity index. So this is something like the absolute viscosity of lubricants decreases with rise in temperature. So we have seen earlier that these absolute and kinetic viscosity both depend upon temperature. So absolute viscosity decreases with rise in temperature, because you can see the molecular structure, the molecules will tend to move farther apart, and there will be much better meaning movement, so that resistance will decrease. That's why it goes down. The rate at which absolute viscosity changes with temperature is called the viscosity index. So this viscosity index is telling about the rate at which the absolute viscosity is changing. High rate of change of viscosity indicates low viscosity index and vice versa. And actually we prefer oils of high index. Then we come to the phenomena of emulsification and oiliness. So emulsification, it is the property which is important for lubricants, as it will make the lubricants useful or useless under particular condition of services. Like we take an example, in case of steam turbines, it is necessary that the emulsion formed by the lubricant with water should separate very quickly and easily. And what is oiliness? Vegetable oils have oiliness, like we discussed earlier, while mineral oils are very low in this property. We have seen this earlier. In order to improve the oiliness of the mineral oils, additives such as vegetable oils and fatty acids like the oleic and stearic acids are added, which we have seen earlier as well. And lubricants which have high oiliness actually stay in their position, that is in between the lubricated surfaces, and they do not come out easily when they are subjected to high pressure. So that's why oiliness property is important. So after discussing these properties, we move on to the cutting fluids now. What good or bad things or advantages or disadvantages they bring in. And so these cutting fluids are used to provide either cooling or lubricating effect, or both. So they can give either cooling or either lubricating effect, or they can provide both the things. That's why cutting fluids are used. And what are their properties? They have good lubrication, low viscosity, so that lubricant can easily fill in the cracks formed on the workpiece. Then they are chemically stable and are non-corrosive in nature towards the metals of the workpiece as well as tool, and they have high thermal conductivity. So they won't be heating the thing at a certain point, meaning localized heating will not occur because they have high thermal conductivity. Meaning, what is the use of this oil actually as a cutting fluid? How it fares as a cutting fluid? So for low speed and high pressure, this oil can be used as cutting fluid. And compounded oils obtained by mixing petroleum oils with vegetable and animal oils are also used for such purposes. Then what about the water as a cutting fluid? They are mainly used for the cooling purpose. What for an emulsion as a cutting fluid. We see that in most cases both a cooling agent and a lubricant is needed simultaneously. Yes, we are saying we need oiliness as well as we need the cooling effect, so that the portion is not heated up beyond limits. For such situations, oil water emulsion is employed. So we mix the two, oil and water. Emulsion is obtained by mixing a small amount of petroleum oil in water, and then we stabilize it by adding emulsifier like soap, fallow oil, etc. And further, to prevent galling, galling is what? Thickening of the concentrate, glycols or alcohols, meaning the compounds which are having OH bonds are added. And besides this, certain germicide are also added to prevent these germs from attacking this particular emulsion. And the examples are like the sodium nitrate. Sodium nitrate is one of the germicide. Then now, how do we select the lubricants? On what basis? For selecting a lubricant for a particular job, the service condition requirements are to be related to the properties of the lubricant. The properties of a properly selected lubricant should not change under service conditions. So that is one of the conditions. And if the properties of the chosen lubricant change during service, then operation will obviously be affected. So all properties described before in this session must be well understood, and their pattern of variation with temperature and pressure should be ascertained before actual adoption in service, because we have seen that there is high temperature range and there is quite a variation in pressure also. So we need such lubricants which can hold its own at both the temperatures or at different kinds of pressures. Several mathematical correlations are available that can be used to calculate temperature rise of the lubricant. So we have to use these things, and such analytical exercise must be performed in advance. And finally, proper design solution for flow change and cooling of oil must be incorporated for smooth operation of machinery. So in this session we discussed about the various kinds of lubricants, like the semi-solid type and the solid type of lubricants. In addition to that, we saw what is emulsification and various other things, and finally we got to know how we have to select the lubricating oils. Thank you very much.